Okay, welcome everyone. Today is April 13th, and this is another of our bi-weekly SIG Apps meetings. My name is Machi, and I'll be your host today. We don't have any particular announcements other than 136 is planned to be released next Wednesday, if I remember correctly, on the 22nd. So if you get pinged by the anyone from this from the release team for 136, please make sure to promptly respond to their pings and help them unblock whatever is needed. And with that, we can move over to the main topic. We have Nathaniel to talk about his proposal. So, Nathaniel, take it away from here.
Thank you. Let me just introduce myself real quick. I work at Amazon Web Services as a scientist and have for about 5 years. I primarily work with the Carpenter folks of late, so working on auto scaling stuff. And I've been talking with SIG Auto Scaling about similar related things to what I'm proposing here. Um, so just a little background. You know, Carpenter, it's a node auto scaling setup. And it has this process called disruption where where it tries to rebalance the cluster after the pods scale in. And you can configure it such that it will, disrupt running workloads and try to restart them on other nodes to, aid in the consolidation of the cluster and cost savings. However, the disruption has a cost to it, and it can make the cluster a little bit harder to manage, especially if it ha happens to have a lot of disruption going on. And so I've been working on a proposal on Carpenter, and I'll actually link it here in the chat, and maybe I'll drop it in the agenda before we close this out. Oops, that's the wrong link. Give me 1 second. So I have a design that I'm doing for Carpenter where it tries to use the pod deletion cost annotation to help the replica set controller aid in the consolidation of the cluster is kind of how I'll put it. So basically, whatever ordering for consolidation, like, within Carpenter, there's a way it ranks the nodes from like best to worst candidate for consolidation. So the way the proposal works for Carpenter is that it'll try to use the pod deletion cost to hint to the replica set controller, um, which nodes would be the best to remove pods from when there's a pod scale in on the replica set level. Um, and it'll probably I've done some testing of it, and I'm still working through it with the Carpenter people. It looks like it'll be very effective. However, what keeps coming up is that it might be better to have at least some of the functionality kind of available within the replica set controller directly, which is why I'm here. Um, so, like the kube scheduler has like plugin type things where you can change how it scores nodes for placement. And so that's potentially one thing we can do. I know that just recently at KubeCon, there was also some discussion of workload aware scheduling and upstreaming some of the Carpenter and auto scaling features as well. And it's worth kind of opening the discussion about does the replica set controller need more functionality, more options, more configurability here to work well with both the node autoscaler and kube scheduler over time. So I hope that's a good introduction with that. What questions do you have? And is there anything you want to dig into more? Mainly, this is just to get you thinking about it, and just know that I'm willing to kind of drive like some of this and do work and submit pull requests and write a design doc or whatever. But anyway, I'll open up the floor for questions.
Mhm. So I know that you linked both of the previous issues that has been happening and where the majority of the discussion has been ongoing for like along now. I will admit that a discovery that I made earlier today regarding the pod deletion cost was that it's actually still in beta and we've never promoted it to stable. And one thing that I can definitely point out, I don't know, pod deletion cost management, whether that's a Carpenter thing or if you're referring to the cube one is definitely on by default
Yeah.
since 122 because that's roughly when we promoted this to beta, which is not so great for sure. And definitely we should figure out what is the path forward, whether we want to expand the scope or whether we want to come up with something that will be more appropriate and will provide a little bit more flexibility to users. And with that, we would basically replace the pod deletion. Um, what is it called? Pod deletion cost
Yeah.
is the feature gate with this new thing. I'm open honestly to both approaches. I was quickly going through the previous issues that you linked, I believe, and that's probably since you're curious. There are basically two topics that I've noticed have gained the biggest support. One was basically talking about building up on the scale sub-resource and expanding it with the ability to temporarily include the pod deletion cost. Although the question that I've been having in my head around how we would, because when you basically submit the scale sub-resource, whatever the values are represented in the scale sub-resource, they have to eventually land somewhere in the etcd. Usually, this is bound to a specific resource. In this particular case, it's a deployment. So, a scale sub-resource on a deployment will modify the replica set, the replicas field in a spec of a replicas of a deployment, which means what happens with the pod deletion costs array, where you're gonna store that thing. And so that's my first question that we would have to figure out how to approach this thing. And then secondly, the question is, and I think that that was mentioned somewhere, but there was no particular answer to that question is how do you find what is the time bound validity of the particular pod deletion cost? Because the assumption was it'll be until the next scale operation. But how do you define what is the next scale operation?
Yeah.
If a user invokes two subsequent, a controller will not know that those were two subsequent because they will when we enqueue a particular deployment for sync, the first thing will already can potentially be already the final result of a scale operation. So that is basically a couple of questions that I had. I've noticed, and I will admit that I haven't seen that before or I forgot about it. There was a comment from Clayton Coleman. He goes under Smarter Clayton. He mentioned that in the hold on, that was basically this comment. He mentioned that in the serving work group, they were discussing this particular one. And he actually expressed an intent to implement not something that will be working only on a replica set, but rather something that will be a little bit more broader. And I started wondering to what degree we are able to actually implement something that will is possible to apply across all the controllers, and that will basically implement will apply to deployment, stateful sets, and whatever else. To what degree it actually makes sense, because as long as for deployments, for replica sets or jobs, at least the non-index one,
Hmm.
it does make sense. Or daemon sets. It less makes sense for stuff like stateful sets, especially if you're talking about the ordered pod manage when you have a very concrete order of which pods will get removed in what order, because that's basically hard coded for the ordered pod management. So that's something that we Um, I think I know it's like almost 2 years old, that comment. And I'm guessing that a lot has happened. But if you're interested in, I would definitely start asking, showing up on one of their next meetings and trying to come at least ask them about what they are thinking about regarding this particular topic. Is there any, I don't know, thoughts that they have done in this? And then eventually we can start to figure out what would be the long-term proposal that we could start working. Whether that will be something that we can address for 137 or for the next one. Um, I will openly say that if you want to work on something and have it done for 137, you should probably start working on an actual proposal as soon as possible because we're slowly closing 137. And if I remember correctly, I looked at the dates. We'll probably start the 137 in a couple more weeks. So would be nice to have something. But
Okay.
in parallel, if you don't have any concrete ideas yet, I wouldn't try to rush it. It's better to have a proper discussion, get the necessary feedback, especially that towards the deadline for the enhancements. It's very hard to get the review from all the people. So being open about, oh, this is something that we are working long term. We're not targeting 137. If we make it, cool. If not, there's nothing bad going to happen because we're trying to solve the problem, not specifically target a particular release. Philip, you have your hand up for a little bit. Go ahead.
Yeah, I would like to go over some of the points you mentioned. So yeah, the graduation is uncertain, and I remember like if it was here in SIG Apps meeting or in some of these issues, there are basically issues with scalability. So even like if your controller can handle the scalability issue, so you have like a tick or a window where you know I'm updating now. Now I'm updating the pods I'm interested in. This doesn't apply like for the feature as a whole. So you could have controllers that are like obsessively updating the annotation and it will basically flood the control plane. So that's, I think, one of the big issues that we would have to subscribe to if we want to graduate it to like stable. And that is also like the minor issue that we really don't like to add features through annotation fields anymore.
Yeah.
So that might also come up if in API review.
Yeah. I actually don't like I mean the annotation's kind of a stopgap because it's there for
Yeah.
Carpenter. But I think the long-term solution is to basically update the algorithm of the scale-in of the pods in the replica set controller. So, you would like right now if you look at how it scales in, like how it chooses, it kind of goes by status and then it goes by deletion cost and then it kind of has this kind of spreading heuristic that it does where it tries to pick pods with more replicas on a node. And that's kind of where I'm focusing in on because that spreading heuristic kind of drives a lot of disruption when you're doing node auto scaling on top of this because it's kind of counteracting the bin packing efforts that Carpenter does. And when I do simulations on it, you can lower the amount of disruption by about an order of magnitude if you change the heuristic in there. So uh,
So
yeah,
I would probably say if you're interested in this topic, 107 598. This mentions a discussion that we had almost 4 years ago. And during that, we were basically covering the pod deletion cost. I was looking again earlier today how one could theoretically implement it. Rather than going blanket, update all the pods, theoretically, because the current algorithm works such that if there's no annotation, it assumes zero. So theoretically, if you are only targeting a particular set of pods, and you did mention that for specifically for auto scaling purposes, when you're trying to decommission a particular node for whatever reason. Theoretically, you could just go and apply the annotation to those set of pods that are running on this node with a negative pod deletion cost, which would basically theoretically mean that they would be the first one because their deletion cost, the current deletion cost as is implemented, it allows you to, I think there's like minus 2 millions or something like that. Basically negative N32 to plus N32 to have a lot of freedom, and that could potentially be a somewhat reasonable. Uh, but I'm guessing that's not the whole point.
Yeah.
I know that someone also, and I can't remember which particular issue, because as I was going and preparing for this meeting, I went through all the issues that I was able to find. Someone mentioned, and those were people. I I think that might have been him, Sanchipo, because he's working on the scheduling side of things. They also mentioned that theoretically a template has the ability to specify a particular scheduling um, constraints for a particular deployment. But those constraints are not in any way applied during scaling down. So maybe
Yeah.
rather than introducing something, we would try to share a code with the scheduler and do a similar calculation and try to figure out maybe we just should apply that because theoretically you already have the option to express whatever scheduling constraints you want for your application, whether that'll be bin packing, whether that'll be a spreading, whatever. But we're
Yeah.
completely ignoring that fact in the controller when we're scaling down.
Yeah.
If we could just reuse, rather than introduce entirely new mechanism, rather reuse what we already have on the pod, that would be ideal because we don't even have to introduce a new API. Because as you probably might figure out, a lot of people already have a lot of solutions implemented, whether that will be through a their own custom controller. I'm guessing some probably already rely on the pod deletion code, even though it's beta and it should not be relied on. So we'll probably have to go through a full deprecation period for that one if we decide uh, to drop that particular one. But if you're eager and willing to do that work, I'm guessing trying to figure out which approach would be the best and trying to come up and write down all the pros and cons of each. That would be super helpful. I'm more than happy to provide you with as much feedback as I can. And if
Awesome.
necessary, we can always I can connect you with the people that I did mention. So whether that'll be people from SIG scheduling, you've already started talking with auto scaling folks. I have a close contact with Adrian and Omar, which I'm guessing you're already working. They are not specifically on Carpenter, but they are working primarily on the HPA bits. I can try to ping Tim Hawk and or Clayton and try to gather their feedback as well. And
Okay.
with sufficient feedback from all the possible angles, we can come up with something that will be very valuable. Philip, who I'll give voice in a minute, also was working on the eviction API, so he has a ton of thoughts
Cool.
and ton of experience going back and forth around node lifecycle management, and he's also driving the entire effort of the node lifecycle management. So he can provide you with some information and how to ensure that whatever the end state will be will also make sense for the node lifecycle working group. Go ahead, Philip.
Um, Yeah, so I would like to like focus on one of the parts like you have been talking about, uh, like which is basically very like should the scheduling responsibility lay. So we can do it as a library, but then you have to update like every other controller, and like it's basically like a difficult problem how you supply like the scheduling logic, which can change like like with one release to another, and like if you have a component that doesn't update, and then you have another one which does, like there is like basically a chance for conflict. Yeah, so like one of the ways I have been exploring is like this eviction request API, like where actually you give an intent for like any disruption or like eviction of the pod. And this does not need to only come like from the scheduler. And I mean, even like a scheduler based. So this can have like multiple signals, which can be also like the node drain, etc. Like, and one of the ways how we could implement this solution for like scheduler aware, like replica set disruption is that we would make the replica set like aware of these eviction requests. And then you could have like a basically in-flight logic that applies like these scheduling constraints, like where you need them. And like we are hoping like to progress with this API with 137, but it's still like a long way ahead. So like if you are interested, you can take a look. I will give a link to the agenda.
That's
Uh, by the way, do you like when you were exploring this solution, like did you expect like to use or like implement the scheduling algorithm like in your component for this?
So there's kind of two paths you can take here. So one is to go like try to basically get the scheduling logic in there. And basically like the end goal of that would be to have like the scheduling logic kind of be everywhere, like from the auto scaling all the way through. And that's probably there's some probably pretty powerful optimizations you could do there. There's another path that's a little simpler, which kind of um, which is where I probably started at. And that's right now you have a heuristic that doesn't care about scheduling, but cares about it's a spreading heuristic. So the other path you could take is, well, let's put a bin pack heuristic in there, and it also doesn't care about scheduling, and then allow people to pick that. That's a less complete solution, but it's also simpler to implement maybe. So I mean, we can there's kind of two ways to think about it from the replica set controller perspective. Um, you know, it when I've tested the simpler solution, as long as everything's been packing, like as long as the scheduler's been packing, as long as the replica set controller's been packing, as long as the auto scaler's been packing, then it all kind of plays nice. But if you have one component that's like spreading and the other two are trying to bin pack, then you kind of get chaos. Um, and so, there's different ways to think about it. Like, but at the end of the day, regardless of how they're talking to each other, you want them all working towards the same objective, however that happens, as closely as possible. It can get pretty complicated with scheduling because you can have weird partitioning and topology and stuff. And honestly, like once you get into that, like if somebody's got a really complicated topology, like you're probably not going to be bin packing very efficiently anyway. But so maybe it's not as important to bin pack. But but yeah, that's kind of where I'm thinking about it.
Yeah, go ahead,
Yeah.
Philip.
Um, yeah, so I don't know if you're familiar, but now like there is this effort between like SIG scheduling and auto scaling to basically move the responsibility to the scheduler, as especially like since scheduler is getting more complex these days, and like you could have and so you have a basically a single source of truth for the scheduling. So I guess like if you can make some heuristic that works for you, I guess that's fine. But there are these limitations, right?
Yep.
And I don't know like what kind of limitations you would be like considering to bring into core. But like for your project, I guess like if you're aware that it's still a beta feature and you're
Yeah.
okay with the outcome.
Yeah, I mean for Carpenter, that's definitely like a short-term thing, except for maybe one or two things that are very specific to the autoscaler that probably don't belong in the replica set controller. I think the ultimate solution is to either add another heuristic to the replica set controller that allows you to align it with the rest of the system better, or, you know, tie into the scheduler somehow to set priorities. The tricky thing about this is the timing issue. And I think it came up earlier, but by the time you want to consolidate a node or disrupt a node, it's kind of too late to do much with from the replica set controller usually, because usually the scaling has already just happened like a minute ago, and now you're scaling it. Now you're scaling the nodes, and the pods are where they are. For this to work best, you kind of need to be ahead of it. And it needs to be, so like if you have a node that's kind of already closer to empty or has fewer pods on it, you want to hit that one first when you're actually doing the pod scale-in stage, and then the node scale-in is then easier because you were ahead of it. And so that's going to be a problem regardless. Like even if we plug in the scheduling logic, like you want to make sure that you're ahead of you're helping yourself as you move down through the stack from pod to node. Um,
Yeah, so this is one of the things like where eviction request could help. It basically tries to postpone or like plan like this disruption ahead. So you could basically select all your pods that you want to be gone, and then like prevent scheduling on the node, and then the replica set would just like we would just have like a simple if this has a eviction request, just remove this pod. And so you would have a control that selects these pods, and I don't know where this control would live. If it is in the scheduler or somewhere else, and it has to be also in its interaction with the autoscaler, so you know like which nodes are like basically like the node scheduling or scheduling of node disruption.
Okay. So do you envision, so like right now it's pretty common to like go to like a deployment and say, hey, scale into this number of or replicas or something like that. Is kind of what you're envisioning, having the deployment goes to like the eviction API and says, hey, plan out, removing 5 pods, or kind of how do
Okay,
you
so
envision
this
it?
is a very complex topic, and I was
Yeah,
just
yeah.
like this. I've
Okay.
been thinking about like the simplest integrations we can do
Ah,
to
okay.
basically like try to offload as much logic outside, so we don't have to implement it in the main controllers. And
Yeah.
like obviously like you could add like such more like better or more advanced behaviors, like, for example, to deployment control to change like the scaling to include like the eviction request like automatically to have like input from other actors, but
Complicated.
yeah, complicated. Yeah, this would like yeah, it's
Yeah.
I see it very, very much less likely.
Yeah. I mean, for this whole workload aware scheduling thing, we may end up ripping out and reworking a lot of the plumbing across a lot of things, but I don't know. But you don't necessarily have to go that route. I think if you have some heuristics across controllers that are aligned with each other, you'll get pretty close to the same results as if you were optimizing across them together. If that makes sense. Like, if they're aligned in their heuristic, you'll approximate what the best result as opposed to like kind of calculating it through some central thing. And in a distributed system, that might actually be better. Like in a huge cluster, you might like it where it's trying to approximate things rather than figure it all out at once, because that can get ugly quickly. So
Yeah, this
anyway,
also depends like what vectors of disruptions you are focusing on. So if
that
you
that does
yeah,
that's a
so
big
if you
one.
are solving only like for your use case of scheduling in like certain scenarios, then it makes sense. But once you try to incorporate like other like plot termination, then you need
Yeah.
probably something more like
And,
complicated.
and that touches on something really important from the node auto scaling perspective on this, is that you want the termination probability to be uniform within the nodes. Um, Even if you have multiple deployments, like different deployments on a node, you'd like them all to have the same probability of being chosen to be scaled in on the same node, because then you're more likely to empty it out if you have a correlated scale in across deployments. Um, and even if you don't, like you set yourself up for fewer disruptions, most likely because you're getting some level of coordination of scale in. Um, so. Yeah, and that's kind of unique to node auto scaling. Like when you get to the scheduling side where you're like, oh, spread this out more or, ensure availability. There's all these like different scheduling objectives that you could have. Those don't necessarily play nicely with like a node bin pack kind of objective. So we have to be careful there. But 'cause, the moment you start taking in like those other scheduling constraints, then you're not going to have uniform probability within a node of scale in. Like if you imagine it, like all the pods within a given node should have the same deletion costs under if your focus has been packing nodes, um, because then you know very likely a lot of the pods are going to come out of the same node when there's a scale in, even if they're on different deployments. So yeah, it's a complicated space, but there are hopefully some simple things we can do to help people out within that. So
Okay. So I believe that the next steps for you will be probably to start. I'll probably just start with a Google Doc or something like that so that it's
got it.
easiest to share with everyone and try to get feedback from um, SIG apps, the serving working group, autoscaling, the carpenter folks. You can definitely, and I'm pretty sure that you should link the proposal that you're working on for in the carpenter. Potentially also with scheduling because based on what you're talking, you're already in touch, especially with the workload aware scheduling folks, and try to gather feedback from all of those parties around your initial version of the document. Once, I don't know, some initial conclusions will be there, we can start thinking about turning that particular document into an enhancement and then just continue working off of the initial issue that you created there. My only ask would be to Ben already pointed also here that you should follow the template because
Okay,
normally if you open an issue, I don't know, let's pick one of the recent ones. The template here helps tracking a particular issue. But for what you currently have, you pointed out the scope and the entire thing, which will eventually be part of the actual enhancement once you start writing one. So when you
okay,
have initial version of the document, you can just ask, like, put a one-liner document and as a discussion link, provide that initial document and then this will only serve the usual tracking purposes to
got it,
for the work, and the document will be the discussion point, and the actual enhancement will be where we'll continue with the discussion. But for
okay,
now, I'm pretty sure that we can just leave it as is, and then once you have those initial steps, we can work off of there.
okay.
If you need any help or anything, feel free to ping me on Slack, either through a DM or on the SIG Apps channel, and I'll be more than happy to help you. I don't know, ping the necessary folks or provide some initial feedback on your proposal.
Awesome. I really appreciate it. Thank you. I'll work
Cool,
up a doc and then we can go from there.
perfect. Thank you very much.
Thank you. It's
I
wonderful meeting
guess.
everybody. Thanks. It
I
was good to
guess
meet you.
that's the only topic that we talked about. Philip also provided you with the links. I'll try to throw the links to all the pieces that I did mention in the call earlier today to Clayton's comment, scheduling comment if I find it again, and I'll throw all the links at the bottom of the agenda.
Awesome.
Awesome. Cool. Thank you very much all.
Thank you.
And with that,
Have a wonderful day.
hope to see you. Yeah, have a wonderful day and hope to see you next time.
You
Thanks.
too.